All right, guys, we are ready for our last section that we're going to cover. So notice we won't be covering 8.5 from your text, but we are covering 8.4, okay, which is all about solving formulas. This will be a big one too for as you think about moving into your next classes, especially statistics, or if you're taking, even if you're taking, what's the next one, Math and Society, that one will be helpful for you too. Okay, so the difference here is that in chapter 8, right, so far we've been solving linear equations, but specifically in 8.4, we're going to be solving formulas. And formulas are slightly different than equations because they are still equations, but they're specifically equations. So a formula is an equation with two or more variables. Okay, so get that down. Note to yourself that there's going to be more than one variable that you're going to see in these new equations. And that makes them more complicated. This is going to be more complicated than the sections you've seen. So read through the text. Stop right now and go read through the text if you haven't yet. And I'm going to just give you some more examples here and probably go through some ones that are in your textbook as well, just you can see them done, right? Because sometimes that helps a little bit better than just reading. But reading will give you a good start on this, okay? So this section starts out with first, just kind of getting one extra step into what we were doing before. So you're seeing here multiple, we have 1, 2, 3, 4, 5 different variables in this formula. But what we're going to do first is still get this down to one variable, because what we're going to do is use this information here that y is 8, y1 is 2, m is 3, and x1 is 5. Now we don't know what those variables are, but we see them over here in this formula. So what we're going to do is substitute in those values and then solve for whatever is left. Okay, so as I run down this list, I see and let me get rid of these underlines so you kind of see this as we go, a y here and a y here. So we're going to substitute in 8 for the y. Then I see a y1, and I look through my list, and there's a y1 that should be 2. So instead of y minus 1, y1, I have 8 minus 2 when I plug in those values. I still have the equal sign there. The next variable I see is an m, and I have something to plug in for that. So I plug in a 3. I have a parenthesis. I want to keep everything in this formula that I have. I'm only substituting in what values I have over here. Now next I see an x. There's only an x1 next. So x is the unknown variable. It's the missing variable. We have a minus sign and then an x1 equal to 5. So I need to plug that 5 in and keep that parenthesis. So go back and watch that again if you don't understand what we plugged in where. We took everything over here where we had a variable equal to a number and plugged it into our formula. Now at this point is a more familiar step that we've seen in the previous sections where we need to start simplifying and solving for this unknown x variable here. Okay, so I simplify on each side first. 8 minus 2 is 6. I can simplify the right-hand side. Or sorry, the left-hand side, that was the left-hand side. On the right-hand side, I have some parentheses I need to simplify. To do that, I multiply the 3 through to get 3x minus 15. This is where I'm going to pick up the pace a little bit because we've seen equations like this before. We need to add 15 to both sides to start solving for x. That gives us 21 equal to 3x. We need to divide both sides by 3 so that our final answer here is that x is 7 with all those values plugged in. And we have our final answer, our missing variable was x. All right, so for the next couple here, that's exactly what we're going to do. So the idea is not to understand, right? This formula looks even funkier maybe, is not to understand necessarily what these variables are at this point, but just understanding that we know that this funky same symbol with the x bar is 7.45. So I see that funky symbol here, that's 7.45 then. That's my complete left-hand side. It only has one symbol. that equals, I have two symbols on the right. The n is 64. So I don't know what this top symbol is. I still have the square root on the bottom, and that square root is of 64. At this point, I need to simplify. We haven't seen square roots in a while. Make sure you grab your calculator to do those, or if you remember the square root of 64, awesome. That's kind of a common one there. So here we have 7.45. Simplify that square root first. The square root of 64 is 8. Now you have a linear equation we're familiar with. We're solving for this symbol in the numerator, so I need to multiply out that 8 that's being divided by my variable. Multiply by 8 on both sides. I get that symbol by itself, so I've solved for it. That symbol is called a sigma, by the way. And when you take 8 times 7.48, you figure out what that unknown variable is, 59.84. So you're going to get used to, in this section, looking at things that you've not seen before, but understanding that they are unknowns, they are variables. Most of these formulas come from a statistics class, and you're just plugging in what they're giving you that you know and solving for the unknown. This is a really good example here of some crazy stuff we haven't seen before, right? But start taking into account what's going on. You see this symbol here, and it's repeated over here in a given. So this entire given is 0.6. So I have 0.6 equals, and I start to realize that these p's go with whatever's in parentheses, and that's an entire unknown. The other known that I have shows up in the denominator here. So what I don't know is p of e and f. That's what I'm going to be solving for. That's one unknown. Okay, on the bottom, p of f was given to me over here at 0.5. So that looked really crazy from the beginning, but here, all I have is that my unknown is being divided by 0.5, so I just need to multiply both sides by 0.5 to get my final answer. So the unknown p of e and f is whatever we get when we take 0.5 times 0.6, which should be 0.3. These are probabilities that you're looking at, okay? So just for some context, we haven't talked about probabilities in this class. That is a big topic of statistics and also of math and society. So you'll see formulas like this in your next class. Right now, again, is to understand by looking at what you're given, what the unknowns must be. All right, oops, don't mean to draw there. Want to move down this chart here. All right, another equation here. Zoom out a little bit so we can see everything. So again, we're going to try and look at these knowns to understand what the heck is going on with this formula. We have this fancy u, it's called a mu, just so you know. We have that summation symbol. Remember here that this means a sum is happening. And we see the xi and the p of xi. Notice that those are the separate things. An xi is like an x1, an x2. And then we have the p of x1, the p of x2. So this is a good one to really look at here. What this means as you break it down is that mu equals the sum over the index I, means we're going to change that index. It's going to start out to be 1, then 2, then 3, and it goes on for however many we have. You'll notice here we have an x1, an x2, an x3, and an x4. So if I break up this sum, it means to take x1 and substitute both indexes with 1, and then add in the next index. It looks exactly the same, it's just that the index has changed. And we keep doing this until we get to our final thing. This one goes up to 4. So I need 4 values here. Okay, now notice these are the knowns I'm given. Sorry, my iPad is frozen here for a second. Let me see if I can get it to work. There we go. Okay, so I'm given x1 is 0. So I know that as I'm looking for mu, because mu is not in my list, that fancy u, x1 is 0 right there, P of x1 is 0.025. These two things are being multiplied together here, so these need to be multiplied together here. 0 times 0.25. Then I will add in whatever x2 is, that is 1 times P of x2, which is times 0.173. Then I will add in x3, which is 2 times P of x3, which is times 0.442. And then I will add in x4, which is 3 times P of x4, which is 0.360. Now it's just a matter of doing the math in a calculator. So the hardest part here, we've done it, okay? The hardest part here is to remember what this sum symbol means. We saw it in both the mean formula and the standard deviation formula. So we have seen it before, but we're kind of using it in a slightly different way this time. We're actually expanding it here to understand what those indexes that I is doing. So here, 0 times anything is 0, plus 1 times 1.73, 0.173, plus 2 times 0.442 should give you 0.884, plus 3 times 0.360 will give you 1.08. Then you just add each one of those together, and your final answer, when you take 0.173 plus 0.884 plus 1.08, and you get 2.137. So again, that final, once you have all the numbers plugged in, it's easy to solve for that unknown, which was mu the whole time. Okay, but that summation symbol is a little tricky. So again, go back through that one if that one didn't make sense. You will see one like that on your homework too. Okay, so you want to be ready for that. This one goes back to something that's a little bit simpler. Okay, so let's see how we do this one. You have E, which is 2.95. So 2.95 equals, T is the unknown. I don't see a T in my list on the right, so I leave that there. T is being multiplied by S, which is 4.83, over the square root of N, which is 9. That's what the formula looks like with each one of these knowns plugged in. Now your job is to simplify. We have 2.95. I need to simplify that square root first, equals T times 4.83 over 3 when I take the square root of 9. 4.83, I can divide that by 3 to get a simpler number here. I can simplify on my right-hand side still. 4.83 divided by 3 means T is actually being multiplied by 1.61. Excuse me. At this point is when I can divide by 1.61. T is being multiplied, so when I divide by it, T will be alone. 2.95 divided by 1.61 is a decimal that goes on for a long time. So this is the point where the homework would tell you to round, things like that. Everything so far has been rounded to 2 decimals. So I'm going to round this to 2 decimals. 1.83 equals T. Okay, so sometimes you will round, and you will especially round anytime your formula is working with decimals from the beginning. Okay, so that was a little bit easier than what we're about to do. Now we're looking at solving for an unknown variable without being given any unknowns. So the whole time, this equation is just D equals B times Q. We do not know what D represents, or B, or Q, but we're going to solve this formula for Q. That means I need to get Q by itself. Currently, this formula is solved for D because D is by itself. So I look at Q and I say to myself the same thing I did when I saw numbers. What is happening to Q? Currently, Q is being multiplied by B. How do I undo multiplication? I divide. So I need to divide by the term that is connected to Q to get Q by itself. Anything divided by itself is 1. So now Q is alone, and there is no simplification I can do on this side, so we have solved for Q. D over B equals Q. Q is alone, and this formula has been solved for Q. You can also think of this, right? The equal sign, you can switch those things around. Q equals D over B. All I've done is flip those two things, right, on either side of the equal sign. So you still think about what's happening to the variable you want to solve for, and you undo those operations. It's just that the things won't simplify because they're not numbers that can be combined. They're different variables that can't be combined. So we just leave those expressions as is. All right, so for this next one, the formula is currently solved for X. We want to solve it for W. So we want to get W alone. We currently have X equals Z plus W minus Y. Undo what is happening to W. I am adding Z, so I can subtract Z from both sides. Okay, if you wanted to move the Y first here, that would be totally fine. I chose to move the Z first. X and Z cannot be combined. This left-hand side is now X minus Z equals W minus Y is left on the right-hand side. W is still connected to Y with subtraction, so I will add Y to both sides. That cancels the Y from the W side, and we finally have W alone. On the left-hand side, I cannot simplify. This is just X minus Z plus W. But W is alone, so I again have solved my equation for W. Again, I can switch those around. If you like to see that unknown by itself on the left, that's fine. Just switch those two sides, write them exactly as they are. All right, what about this one? Again, you're starting to see some symbols you don't recognize. That's okay. What you want to do is solve it for X. So we want to get this X that is currently in the numerator of a fraction by itself. So I'm going to rewrite this equation. Z sub 0, also called Z naught, equals X minus Y sub 1 over that fancy symbol called the sigma. I want to get X by itself. Currently, the side that X is trapped on, the entire side is being divided by sigma. So just like we learned in 8.3, if the entire side is divided by something, multiply it out so you don't have to work with fractions anymore. That will get rid of that denominator. On this side, I cannot combine these two things, so I just have those two things being multiplied together. We have sigma times Z sub 0 equals X minus Y1. I'm solving for X, and currently X is still connected to Y1 with subtraction, so I will just add the Y1 variable to both sides to cancel it from the right. That will leave me with a sigma times Z naught plus Y1 equal to my X variable. And again, I have solved for X. Also, I can still write that as X sigma times Z naught plus Y1 either way. Okay, either of those two answers are correct. X is alone. It is solved for X. All right, let's look at a couple more. This one's got a number in it. That's all right. We're going to solve still for Z, which is currently not alone on the left-hand side. Now this one's kind of interesting here. We have X over Y plus Z over W equals 2. Now here's my unknown right here that I want to solve for. That means that this entire term is just being added to a term with my unknown. That means I can just simply subtract this entire term from both sides. It will move that term away from the unknown I want to solve for. 2 cannot be combined with X over Y. There are no common variables there. So now we just have Z over W equals 2 minus X over y, but I can move that entire term because it's being added to my z term here. Now my z, the last thing that it's being done that I need to undo is multiply out that w. But remember, anytime you have something complicated on a side and you're multiplying, you need to make sure to put parentheses around it so you multiply that w by everything. That's a huge component here. If you forget those parentheses, you're going to be wrong. Now you do not need to distribute though. You can leave this right-hand side as is, or you can distribute, either one is correct, but you have to have the parentheses. Parentheses 2 minus x over y times w. You could write that w out front of those parentheses as well. That's kind of the more preferred way, but this is perfectly good. So a very key step right there. If you're multiplying by something and you have addition or subtraction already going on, put parentheses around what you're multiplying by. All right, let's look at one last one here for some more examples, and then hopefully you'll be good to go for the homework and you can try some of these. Okay, we saw this formula actually when we were plugging in unknowns, but this time we're not going to plug anything in and we're just going to solve it for n. So I'm going to jog your memory back to how to solve for something with a square root. Okay. Also, right now we're looking at an interesting equation where the thing that we want to solve for is in the denominator. If whatever you're trying to solve for is stuck in the denominator, start by multiplying it out of the denominator. So we have, let me change this real quick. Make this a little easier to write with. Okay, sigma x bar equal to sigma over the square root of n. So the first thing I want to do is multiply out any unknown that I need in order to get it out of the denominator so I can actually work with it. So I'm going to multiply out that entire term that combines the unknown that I'm actually looking for. Okay, so then now what I have is the square root of n times sigma x bar times another variable equals sigma. I want n by itself. Currently, it's being multiplied by something, so I can divide off whatever it's being multiplied by on both sides to undo that and start to get n by itself. I have the square root of n. These cannot be combined. Those are different variables. They are not both sigmas. One has a subscript. So we just have here sigma over sigma x bar. The last thing you need to do is remember how to undo a square root to get n by itself. You will square something in order to undo a square root. That will leave n alone, and we will have just exactly what we see here. Sigma divided by sigma x bar, that all needs to be squared. And n is alone. That might be one that you need to watch again, okay? 2 tricks there. Always multiply out by the denominator if your variable is in the denominator, and square something in order to undo a square root. That property is discussed in your text as well. The last topic I want to cover from this section and these notes is a major application we use. Solving for that unknown variable really helps us graph equations. So before, we were strictly given equations in this y equals mx plus b form, and that allowed us to plot the y-intercept and use the slope to graph the function. But when I have a function that isn't in that form, I can't easily graph this function. But what we know we can do now is solve for an unknown. So I'm going to take this equation and solve for y so it's in this form. Okay, so we've got 2 times x plus 3y, and we're going to put it into slope-intercept form by getting that y alone. That means that I need to move the x term first, so I'm going to subtract it over, right? I'm moving an entire term, so I can subtract or add it. I will need to subtract it to make it 0 on the left-hand side. That leaves me with my y term alone, and that's 9 minus 2x over on the right. Now, another step I want you to realize is that I can rewrite this so it's in the same order as my normal y formula. You can do that at any point. I'm going to go ahead and do it now. That's the same thing as negative 2x plus 9. The key there is to take the sign. So the 2x was negative, so it's negative here, and the 9 was positive, so I added it here. Now our final step is that we have to divide by 3. The key here is that this entire side gets divided by 3. So when I put this into slope-intercept form, what I have here is that the 3's cancel and I do get y alone, but each one of the terms on the right-hand side is divided by 3. So that's negative 2 over 3 times x plus 9 divided by 3, and 9 over 3 is 3, so plus 3 here. And now I have y by itself, and I can easily graph that function. I know that should cross at 3, so here I am crossing at 3 on my y-intercept, and my slope is negative 2 over 3. That means I need to go down 2, right 3 from that y-intercept, or up 2, left 3, right? You need any one of those 2 points, and then you've got some points to help you graph that line, and we've got it. Okay, so we can use those techniques to solve for an unknown variable to really help us plot lines. We're going to do this a couple more times with a couple different scenarios to help you out here. Okay, so this one again, your goal is to get y by itself. Currently, everything is on the same side. So we have 4x plus y plus 2 equals 0. We need to get y by itself, so let's just start moving those terms over to the right-hand side. That means y plus 2 equals negative 4x. And this time, all I needed to do is subtract the 2, and I'll have y equals negative 4x minus 2. Keep track of those negative signs, and you've got it right there. Y is by itself. We didn't even have to divide in that case. So I plot this by plotting the y-intercept, which should be at negative 2. And then by using the slope, thinking about that as negative 4 over 1, means I need to go down 4 and right 1. And getting as best of a sketch as I can here of that line. Okay, let's try one last one here. This one just has some more simplification to do. We see some parentheses, and that y we want to get by itself is trapped in them. So let's distribute to get rid of those parentheses. That'll give us 3x minus 6y equals 9. And now we're at similar steps we were to before. We need to subtract the x term in order to get it to the other side. That cancels it on the left, leaving us with negative 6y equals 9 minus 3x. Okay, at this step again is where you can reverse that order so you can clearly see the slope. That's the same thing as negative 3x plus 9. And then you still need to divide off by the negative 6 though. Y equals, divide both. I'm going to do that kind of in 2 steps this time to hopefully help you see that a little better. Negative 3 over negative 6 is on x plus 9 over negative 6. Both terms get divided by negative 6. So what does that give us? This simplifies, do it in your calculator, do it by hand. That simplifies to 1/2 times x. 9 over negative 6 simplifies to a subtraction. 9 and 6 have that common factor of 3, so we end up with subtracting 3/2. Okay. Now there, that's going to be a little bit harder to plot, but that's okay. Everything's going by 1 at this point, and we want to cross at a y-intercept of negative 3/2. You won't have one quite this hard on the homework, but just a little practice doing some graphing here. So negative 3/2 would be down 1.5. Okay, so we're going to start down 1.5, which would be right there, halfway in between negative 1 and negative 2. And then we'll still go up a whole unit and right 2 units from there. If we go up a unit from -1/2, we'll be at -1/2, and we'll go right 2. So that graph, sorry, that should be at a half there. About right there. Oh, goodness. And that's just going to be harder for me to graph on this iPad, but that'll be halfway through. There we go, those 2 points there. Okay? It's a little bit harder to graph that since we had kind of a weird y-intercept. Hopefully that didn't confuse you too much. But you get the idea here. We've solved for y. Hopefully you get the idea here. We've solved for y by following those steps to move terms around and get it up by itself. All right? So hopefully that helps you understand this section, but if you're still stumped, make sure you're reaching out, okay? All right, guys, that was the last section, so hopefully that helps, and we'll be talking about the final next week, okay? See ya.